So next problem solving question, data handling from the 2008 paper question 6. Okay, we're back to context again. If you have not read this carefully already, then you need to do so. So press pause and do that. Make sure you know exactly what we're talking about. Next one is the data. So you have quite a complicated graph. You've got three sets of lines here. So you've got the average rate of water loss in kilograms per hour per kilogram of tree. So that's so you can compare different sizes of trees. You've got three different types of tree. You've got the cherry laurel, the white oak and the loblolly pine. And then we've got our time in days running from 0 to 70, and then going up the side, as I say, we've got our water loss, but just to be absolutely clear, so that would be 0.5, so each of these divisions is 0.1. It is worth knowing what your divisions are because you're going to have to read off data at some point. Okay. First question says, using values from graph 1, so we obviously need graph 1, describe the changes in rate of water loss from loblolly pine over the 70-day period. So it's another one of these describe questions. You have to be absolutely precise and you have to give all of the data points that would be needed. So we are looking at this line here, the loblolly pine, not any of the other ones. And so you look at the line, you go, well, there's my end point, I'm going to have to give that. There's a kind of peak, so I'm going to have to give that one and the point at which it went down. And the rest of it is okay, I can just give a trend. So there's my points. I have 4 points to give, which is not surprising for 2 marks. So the points that you're going to have to give is on day 0. So you got on day 0, you have, what are we saying, 3.1 centimeters cubed per hour per kilogram water loss. Okay, falls to, where are we going next, point 0.6, falls to 0.6 centimeters cubed by day 40, increases to 0.9 by day 50, and then decreases again to 0.4 by day 90. Oh, sorry, 70. Yep, there's your points. Oh, I've actually missed out a unit here, which I should have put in. It's really important that you give a full unit, you know, so that you've actually said exactly what you're talking about, and then after that you can start to do a slight decrease in how you're putting it, but you can't completely leave your units off. Be precise about it. This is the second one of these that I'm recording, and it's been the first question each time. And then we have a percentage decrease. So you're very likely to get percentage change questions now. You're not going to get percentage, just a straight percentage question. You might, but it's going to be complicated. They're not going to give you an easy one. So it's going to be probably percentage increase or percentage decrease. So the percentage decrease in rate of water loss from cherry laurel, so now we're looking at this line, from between day 0 and day 50. So here's your day 50 point, and here's your day 0 point. Okay, so ignoring all of the ups and downs of it, they just want to know how much has changed between the start and the end. So change, whether it's increase or decrease, divided by start times by 100. That's what you're looking for your basic thing. Okay, so our start, we can get here, our start is 4.8. Our change, well, we started at 4.8 and we went to, over here, 3.6. So we have changed by, where are we going? 1.2. So 1.2 and then times by 100. That's actually quite nice. If you look at it, that's just a quarter. So, but obviously do the sum in the calculator so you don't do anything weird in your head in an exam. From graph 1, let's bring up graph 1. The simple whole number ratio, the rates of water loss from white oak and cherry laurel on day 20. So I am looking at the white oak line, so that's the cross here, and I'm looking for the cherry laurel here. So the white oak, if I read across, is 2.2, and the cherry laurel is 4.4. You obviously don't get the mark for that. This is not a whole number. Okay, but it does cancel nicely. There we go. Okay, so using the information from the table and from graph 1, notice it is in bold. If they put stuff in bold, they really mean you're going to have to go and use it. If you don't mention information from both of these sources, then you can't possibly get the mark because it says and. So the table is the original table from the original context and the graph 1. Okay, so we need to say why it would be advantage to the white oak of losing its leaves in winter. So here's the white oak. The white oak is a broadleaf type and loses its leaves. So your comparison is going to be here, because you've got another one that's a broadleaf type and it doesn't lose its leaves in winters. So if we look at the white oak, here's the white oak, which is losing, oh no, that's not the white oak, sorry, this is the white oak. Here's the white oak, and you can see it's losing less and less water, which is going to be of an advantage to it because it's losing less water that can be used for other things. So there's less water loss by transpiration, and therefore the water can be used for other things. Here's the cherry laurel. Change colour, maybe it's something a bit brighter. There we go. The cherry laurel is up here. So it's got the same type of leaves. Oh, that's a little bit wobbly in that one. Never mind, you know what I'm saying. And that is losing a lot more than the white oak. So that's how you can use both of these sets of data, by explaining why you would pick the cherry laurel to compare to the white oak, by the fact that they are both broad leaves and the fact that one of them loses and one of them doesn't. So your advantage you have to kind of come up with in terms of transpiration, less loss from that, but your justification is going to involve the comparison. Okay, some more data. In a further investigation, the effect of air temperature on the average rate of water loss from loblolly pine was measured. Okay, so we have a water loss thing, that's fine, and then we've got air temperature going along the bottom. See this gap here, the fact it doesn't go up to here? This, as soon as you see this, it means you're probably going to have to extrapolate out from the graph. But this is otherwise quite a straightforward, nice graph, and this is again going up in 0.1s, so that's a nice, easy one to read off. Okay, use information from graphs 1 and 2 to suggest the air temperature on day 30 of the investigation. This is in bold, it's both of these graphs, so you're going to have to use both of them. Day 30. So remember as well, this is about the loblolly pine, not any other one. So day 30, the loblolly pine lost 1.4 centimetres cubed per hour per kilogram of tree. So what I've now got to go and is find 1.4. So 1.4 is here, and if I read this across, sorry, trying to do this is not the easiest on here. So this point here, I can now read this down to work out what the air temperature was. This is going up in 0.5s, so there's 1, 2, 3. So what was the temperature? 3 degrees C. Okay, predict the rate of water loss from the loblolly pine at an air temperature of 18 degrees C. So remember how I said this was still going? So this is actually 20. So 16, 17. Here is my 18 here. And this is going in a very straight line. So I'm going to have to try and continue on this line, which is not going to be easy on the computer. But you could use a ruler, would be better. So I think that's not bad. Okay, so if I take my 18 up, there's my point there, which is 3.3. There will be a little bit of give. There might be a little bit of give, actually. I'd have to check the mark scheme for that one. Given how straight that line was, it might not be very much at all. That's it. Apart from air temperature and soil water, State one factor which can affect water loss in trees. Now I left this in purely because it's actually a National 5 question. In terms of water loss, you just got to think about anything that would actually increase the transpiration through the tree. So it could be humidity, it could be airspeed round about it, whether it's windy, anything. There's a list on the mark scheme. Make sure you've got something that actually follows to it. Right, so here's the official Sqe Mark Scheme. If there's anything that you're not sure of why, if you would have got it, notice that actually there we go. So it was accepting anything between 3.25 and 3.3. That is not a lot of give. And the reason this 3.5 is in here as a wrong answer is because if you'd taken the line up to the top, that would have given you the 3.5, but that would have been at 20 and not at day, or not at temperature at 18. Okay, that's you.